Most investigators agree that organic material is the prime source of petroleum. But there is a lot of disagreement as to the actual physical and chemical processes involved in the transformation of the organic material into complex hydrocarbons. The essential conditions for the transformation can be seen on the next page. There are 5 fundamental ways that petroleum can be formed. First, the deposition of organic matter in an oxygen-free environment. Second, by bacterial action. Third, by temperature. Fourth, by pressure. And finally, 5, by catalytic reactions within the formation. Hydrocarbon migration is an interesting topic. Simply put, hydrocarbons originate in fine clay sediments. Hydrocarbons, along with formation water, move out of the shales as the formations are being compacted. So therefore, even though they are created in these shales, they almost always will move out of them. The migration is normally vertical, that is, upward through various overlying formations. When the upward migrating hydrocarbons find a porous and permeable body of rock, it lodges itself in it. Then it will migrate horizontally in the same formation until it finally becomes trapped. As we stated previously, the hydrocarbons will move horizontally through a formation. The accumulation of hydrocarbons in quantity in a reservoir rock and its failure to move out of such a reservoir rock due to a trap leads to a commercial oil or gas pool. The hydrocarbons are found accumulated in the pore spaces of reservoir rock much in the same way water is retained by a sponge. As we said previously, hydrocarbons will migrate horizontally until they reach something in the formation that will trap them. A trap is a geologic structure or a stratigraphic feature capable of retaining hydrocarbons. Hydrocarbon traps that result from changes in rock type or pinch-outs, unconformities, or other sedimentary features are called stratigraphic traps. Hydrocarbon traps that form in geologic structures such as folds and faults are called structural traps. Any mixture of structural and stratigraphic elements is called a combination trap. All of our discussions of hydrocarbon traps and migration can be summed up right here. Take a close look at the diagram legend. The overburdened rock, that is, the rock above the reservoir, is indicated by a light tan color. The seal rock, the rock that actually prevents the hydrocarbon from further movement, is indicated by the light green color. The reservoir itself is yellow. The original source rock, that is, where the hydrocarbon originated, is in dark green. The underburden, that is, the rock below the reservoir, is in brown. The basement rock, which is usually granite, is black and white crosshatch. The petroleum reservoirs are indicated by the black pool, and faults are indicated by the curved up and down arrows. We had even provided the contacts between the oil and the gas. The oil is in the light red, and the gas is in the light blue. What this means to you is that hydrocarbons mature in a source rock, then migrate upward to a formation that can both contain the material and keeps the material from migrating further. You will also notice the now familiar syncline-anticline structure, which will assist in the accumulation of the hydrocarbons. If you can understand the mechanisms presented here, then you have a fundamental understanding of the life cycle of a petroleum system.